Morrison's, we're cutting the price of hundreds of essentials across your big shop. Like a 4-pack of large vine-ripened tomatoes was £1.40, now £1.19. Chicken breast fillet 630 grams, worth £5, now £4.65. And a 3-pack of onions was £1.10, now 95p. Oh, and loo roll, laundry pods, pasta, gravy granules, and more. That's hundreds of prices cut across your big shop.
More reasons to shop at Morrison's.
Majority of stores, excludes Morrison's Daily. Online may vary.
I can feel it somewhere inside, haunting like a drug I keep on wanting. There's a love that fits so perfect it's hard to believe. There's a reason I can feel my heart stop beating, and the air gets tough just breathing. I'm alone but I'm still feeling like someone's with me. It's strange, I know, but I feel like you're here with me, like chasing ghosts. I know you're out there. Time is unfair, 'cause I know you're out there somewhere, patient, waiting unaware, feeling like your grip might slip too soon. But I'm running, chasing speed and gunning. I'll be right there all of a sudden. I feel your heartbeat lead me straight to you. It's strange, I know, but I feel like you're here with me. It's like chasing ghosts. I know you're out there.
Good evening and welcome everybody, my name's Obi-Wan Pez, this is Simplex Pachinko, and we are going to be talking more about building thinking classrooms tonight. So, hope everybody has been having a good start to your week. Make sure that doesn't fall over. There we go. I may be a little more verticalized today. I don't know exactly what got changed on resolution, I guess. Some stuff's a little weird, I think, maybe. It's fine. Alright, let me know if any balance issues are cropping up or anything like that. And I will turn this down to my ear. And now we have... how long left? 58. Alright, so for the first 50 minutes... we're going to try to go through the problem and potential solutions. So, how do we foster autonomy in a thinking classroom? We are working out of, for anybody who does not know yet, Peter Liljedahl's Building Thinking Classrooms, which is supposed to be for mathematics K through 12. I taught this in a community college setting for, well, I used a few of the practices for about a year, and I was able to use all of the practices in one semester. With some success, but we'll discuss more as we go on in terms of what worked and what didn't, what I saw as well as what the research bore out. So, more or less reading from Peter Liljedahl himself, and then I'll throw in commentary whenever it comes up. Whether or not you've been implementing the practices as you have been reading along, and for anybody who's out there watching, hi, how's it going? You'll now have concluded that a thinking classroom looks very different from a typical classroom. Students are working in groups rather than individually, they're standing rather than sitting, the furniture is arranged as to defront the classroom. Closer inspection will reveal that the teacher is giving instructions verbally, is answering fewer questions, and has drastically altered the way in which they give homework. Remember that for all of these so far, the targets that we were looking at were, first of all, visibly random groups of 3, and defronting the classroom. Actually, that's more of a group 2 element, but nonetheless. This is an easy practice that you will be able to do in practically any classroom. It doesn't matter where you are, as long as you have the ability to move your desks. And even if you don't, you still will be able to defront the classroom by placing yourself somewhere else. Alright, visibly random groups of 3. Standing at vertical, non-permanent surfaces. As able, obviously. Defronting the classroom. Okay, so these are the things which he mentions immediately. Also keeping in mind that the other things we have done so far, which are not listed here, is we decided to start with a non-curricular thinking task. When we go back here, look at the practices as they're listed. Okay. Our students work how we arrange the furniture, right? How, when, and where the tasks are given. Give me 1 minute, please.
We like to think we have some form of control still, making our constant binary choices and voicing our equally shallow opinions more loudly or quietly. Most people can't even decide what color to wear or which burger to eat. Well, does it matter, man? Autonomy is an illusion. Autonomy is an illusion.
All right, anyway. Oh dear. Okay, right. So I need to stop using the chapter titles here, or the problem words, and start using the solution words. Tasks given standing loosely clustered around you verbally. Within 5 minutes of addressing the class.
Where or which burger to eat. What does it matter, man? Autonomy is an illusion.
And how do we choose to answer questions?
Autonomy is an illusion.
Thank you, Spotify. It said something about autonomy. That was awesome. All right, and the homework is for check your understanding purposes only, not marked, not even referred to. Answers.
Toy starts to run out of
given immediately.
Arriving today with Amazon Prime. Everyday essentials delivered fast. It's on Prime.
I'm Professor Huggington.
Full solutions.
T's apply. See product page when ordering.
There are some things you'll never understand. Like, why did that person go
Follow 1 to 2 days later.
become socially acceptable? And how come that dinosaur theme park keeps reopening, given its safety record? But some things you can understand, like your Experian credit score. The more you improve your score, the more you could save on things like
Okay,
credit cards,
so this is what we have so far.
mobile contracts, and more. It's
Again,
dead easy to
start
check.
with a non-curricular thinking task every single day, every new class. You can use the same one between, class 1 and class 2, but use visibly random groups of 3. About once per hour, they need to be re-randomized. At a community college setting, I just said once per day, and that was it. We did get some challenges with that, but we can talk about it. I guess I have talked about it during that chapter, but for the most part, worked fairly well at breaking up any kind of social structure that was there, trying to get people to hang out with different groups of people and figure out how to work with different groups of people. In addition, friends do not work well together typically, so it also makes sure that everybody gets a chance at various points during the semester to be kind of in a different role than they're typically going to resign themselves to. Standing at vertical non-permanent surfaces to work, defront the classroom, so make sure that you are moving around and there is no front to the classroom. Give tasks standing, loosely clustered around you, verbally and within the first 5 minutes of addressing the class. Answer only, keep thinking questions. So if anything is a stop thinking question, like, is this right? You want to bounce that. Be like, what do you think? Tell me. Can you explain this? And if they can't, you just kind of smile and walk away. Some other stop thinking questions just deserve a small smile, and you keep circulating. And then they'll eventually be like, I should stop asking those types of questions, because he's just not going to do anything with them. And again, homework is now shifted over to check your understanding. It is for them to do, and it is not for marks. It is not even referred to. Don't say, like, get out your homework or get out your, anything that you worked on, whatever. It is completely optional. Students can work on it or choose not to. And again, about 20 to 50% of the students will choose just not to, but that percentage was higher when it was marked. So, or the ones who handed in absolute nonsense and cheated and various whatever other things they did. When it was checked, when it was marked, they weren't doing the work either. So having somewhere between 50 to 70% of the students actually doing the work because they're checking their own understanding is a vast improvement. Okay, again, give the answers immediately when it's assigned, and then give the full solutions 1 to 2 days later. So, as for student autonomy, all of these changes require greater independence on part of the students. So this becomes a potential source of a problem. All right, This chapter will look at how you can begin to build this independence through giving students more autonomy over their own actions, and how this autonomy not only changes the way students engage with the thinking classroom, but how it makes the teacher's job easier. Hey, Famished. So, from a teaching perspective, one of the biggest differences that you may be experiencing or anticipate experiencing is that in a thinking classroom, you, the teacher, have a lot less control over what's happening in the room. Which, for me, was a challenge. When students are sitting in desks, all facing forward, presumably following along with what's happening on the board, the teacher has a lot of control over what is outwardly happening for all of these students at every moment in the entire class. In this moment, the students are all doing notes. In this moment, the students are all doing "now you try one" questions. In this moment, all the students are starting their homework, etc., etc. Everything is sequenced, paced, and synchronized so that every person is doing the same thing at the same time, or at least, so it seems. We already talked about a few examples where the teacher thought that the student was working, but that's not really what they were doing. So outwardly, traditional classes will look ordered. Students are all seemingly engaged, but again, all they're really doing, probably, is to fill the social role of student. So, it doesn't quite work necessarily. It worked great for me, right? Because I was paying attention, I understood what was going on, I could follow the teacher's reasoning through whatever, and then here was some examples. I could do the examples. When I get home, I could do the I could look at the examples and do the mimicry of doing the problems that were given, until I hit that brick wall. Often, there were just little road bumps. When I was in middle and high school, I didn't really notice, but then once differential equations rolled along, like I said before, once it was differential equations, then suddenly I couldn't do that anymore. I was not able to just mimic my way. Yes, definitely take some trial and error to figure out what's best for you. I find that looking at as many perspectives as possible is really what gets me to where I need to be. I've been working on Dr. Pavel Grunfeld's tensor calculus, which is downstairs, I believe, at the moment. Still in my bag, in fact. Never took it out. We went to London this last weekend, so we had a 4-hour-ish train journey each way. Yeah, never picked it up. But trying to figure out the tensor calculus stuff, like, I don't have any real examples to work. I don't have. I mean, I've got lectures online that he did, but like, there's not a whole lot of material that I can just go and hunt down, right? So, hi, 1 second.
In the darkest night, I saw your eyes. A sense of threat that I can't forget. I wanna know who you are. This what I need to
Okay, hang on a minute. There's a crisis.
fears go. Take me to your jungle, where the rain is warm and the birds fly. Take me to your kingdom. Yeah, take me to the. Yeah, take me to the. Take me to your jungle, where the rain is warm and the birds fly. Take me to your kingdom. Yeah, take me to the jungle. Darkest night, I saw your eyes. A sense of threat that I can't forget. I wanna know who you are. Is what I need to know. So take my hand and let our fears go. No words describe your savage life. Ooh, let's give it a go like our purpose shows. I wanna know who you are. Is what I need to know. So take my hand and let our fears go. Take me to your jungle, where the rain is warm and the birds fly.
Okay, it was big. If anybody doesn't like spiders, look away. But, that's what we got there. That's a big one. Whew. I mean, its body would probably fit on a nickel. We're gonna just chuck this guy outside here. Yeah, I know, you don't want to go. I don't want to go either, quite frankly. Okay. Well, anyway. Yes, 100%. And it is, in fact, raining, and also the wind was coming in, so I was like, hoping that it did not, in fact, come back in. It's fine. That might have been the one that was crawling on the back of my monitor, like, a week ago. It crawled over the corner of the monitor, looked at me, and then just crawled right back. I was like, If it's the same one, it was much smaller. If it's not the same one, okay, well, it was a smaller one. Okay, so anyway. Outwardly, right, traditional classes look ordered, the students are seemingly engaged, but typically they're only fulfilling the social role of student. So they're trying to be good students without necessarily knowing anything. So that's one of the things, is that kids who typically don't, and I'm saying kids in a not pejorative, but in the sense of younger students, right, especially those who are in middle and high school. They are legally children for the most part. They are legally children for the most part, so, you know, kids. So a lot of those kids make up for not being able to understand something by trying to please the adult in the room. And that is exactly what we do not want. We don't want students to skimp on learning just because they can get away with, you know, looking like they're understanding something or looking like they're doing the work, even though they're not. So building thinking classrooms is about making sure that the students are actually doing the work and actually moving forward and trying to learn stuff. Waffle Lover, good evening and welcome. My name is Obi-Wan Pez. This is N Simplex Pachinko. Tonight we are working on, when we're not interrupted by the kids, Building Thinking Classrooms by Peter Liljedahl. This is math education, and this is a particular method that I worked on with, like, transferring one of my classes, transferring all of my classes to doing some of it until my final semester in the in the fall of 2023. So yeah, it's been 2 years. That was my last semester, and at a community college, and I'm trying to kind of give the gist of how it works, that it actually does, for the most part, work, and my experiences with some challenges that I had, which I think mostly are me problems more than the system problems. But anyway. We also do gamey type stuff on Sundays, Tuesdays, and Fridays. So if you're interested in any game type stuff, feel free to come back any of those nights. Currently, we're working on Satisfactory, which we just did last night. 9 Souls, which we're doing on Tuesdays, and Against the Storm, which we're doing on Fridays, with occasional Elite Dangerous sprinkled throughout. If you have any educational questions or goals or anything like that, let me know. So, the gist of the first 7 chapters... Vectors, absolutely. Gist of the first 7 chapters we had here. For anybody else who wasn't around... And then do you have a particular specific question, I suppose? Or just like vectors? Because I could do a like vectors lesson, but I don't know where you are. Okay. So we said from earlier, the studenting research presented so far what goes on behind the facade of this social role of student is quite different from what we intend as teachers, and in fact what we end up seeing in the classroom. Regardless, there is structure. The stronger the structure, the lesser the need for the students to be independent, and the lesser the need for students to have autonomy. And they just rely on you to do everything for them. And again, we said that the problem here is that the students will, in fact, let you do the work. And then they don't learn. Simple as that. So, lack of autonomy is synonymous with lack of choice. You're in middle school trying to get ahead now, focus your time in the future to pay off student loans. Yeah. Alright, so let's go left here of this one. Algebras 1 and 2. Okay. So typically, you've got kind of 2 styles of vectors. Alright, so break here for a minute, everybody, and can zip ahead to, hopefully I'll get a chapter marker on here. Or we'll, I usually have the, or I haven't done it yet, but I'm going to get the timestamps of all of our individual problems. Alright, so generally speaking, right, vectors are going to be right? It is a directed line segment. So that is physically what it is, and what it represents is a magnitude and a direction of movement. So typically, well, not necessarily movement, but a magnitude and a direction. Yep. So typically what you're going to get is something that looks like this versus one that looks like that, versus one that looks like this, versus one that looks like that. Right, they could be from the origin to any particular point in the plane. So sometimes you'll see vectors written as arrow brackets. I don't know what else you call them. And then they have their particular location. So this is like 4, 7. Right, so we can go 4, 7 inside angle brackets. Are they always linear? Yes. Now, the thing that they're representing does not have to be linear. But what we're doing is we're saying that let's say it's a force, right? It is an instantaneous moment in time. What is the direction and the magnitude of that force? And if it's like multiple things happening at the same time, it's going to be like, what is the average of all of these things? Alright, so we go like this, 1, -2, we get -5, -2, pretty close, and -2 by 4. So the way you add vectors is a little bit different. If you just wanted to know, like, what is the average force that's happening between these 4 forces that are acting together, it's not actually going to be add and divide. So all that's really going to happen in this case, if you're looking for the resultant,
Majority of stores excludes Morrison's Daily. Online may vary.
Yeah, I'm one of their biggest fans. I've got all the vinyl.
is just,
At a tiny little place in Camden.
these are added up.
Then as festival headliners a few years
And specifically, you're going to add up all of your X directions, and you're going to add up all of your Y directions. So this is just going to be like straight addition all the way down. So 4 plus 1 is 5, minus 5 is 0, minus 2 is going to be minus 2. And then going down the other column, 7 minus 2 is 5, minus 2 is 3, plus 4 is 7. Okay, well, you know, it works. Oh. Hey, Stick, how's it going? So, taken together, all of these things, if it was a force, is going to add up to this. So let's say it is, you know, the you're in a boat. Right? You have the direction of travel, which is going to be the big one. Let's just... I'm making this up. Tons of cooking to do? Nice. Right, so this is the direction of travel. We're going at this particular speed, or at least in theory, it would be that kind of speed, right? Let's say that this one is the wind. This tiny one right here is a wake from another boat. Right? It's going to hit your boat and cause it to go this way instead of that way. It's trying to push it off a little bit. The wind's coming this way. And that last one, I don't even know. What else could we make? A water current, right? The blue one's the water current. So all of these four things could be acting on the boat at the exact same time. Right. So you end up, based on all of these things coming together in the exact same way, right? It's all acting just slightly differently, but it's going to take your boat, and instead of going that way, it's going to kind of drift this way instead. If you change the angle of the boat, you're going to change your 4,7 vector to do something else. And based on what's happening with the other stuff, obviously the wake, the current, and the wind aren't going to change significantly in the next like 5 seconds or something. Let's just suppose. You're not crossing into a different area or any specific features of the water or the wind. Your direction of travel just changes. Now that's going to cause the vector to be slightly different. So when you're talking about the resultant vector, this is just vector addition. Now we could also call these by slightly different names. So instead of doing 4,7 in these angle brackets, we could call it 4x hat plus 7 y hat. Or we could call it 4i hat plus 7 j hat. So instead of having, and I just learned this off of our one-a-day calendar, instead of having the usual tittles on the top, which are these single little dots over the I and the J, you now have a hat. It's essentially, I only know the French word for it, accent circonflexe. So yeah, put the hat accent on top of the I and J, and the X and the Y. It all means the same thing. It's just how you define your particular direction field. So here, typically, again, we're calling this X hat and this Y hat. Does it actually matter? Nah, not really. You could have all sorts of weird directions, but we're not going to worry too much about it. Alright, so they unclip from the dock, and that's at the origin. The boat was the segment, the path would be the vector. So the current, meaning at this exact moment in time, not current, the at this moment magnitude and direction of all four of those forces, or all four of those individual movements, is going to be each of the individual vectors. So what's happening really is that the boat is always at the origin, because that is what we're referencing everything from. So we're saying we're acting on the boat. So the boat is going to be the origin every single time. Good evening, Zach and party. How's it all going? Anybody who doesn't know me, Volk nicht.
Hello there.
I'm apparently in that group too. No, what? So yeah, hi and welcome everybody from the raid. My name's Obi-Wan Pez, this is N Simplex Pachinko. We are going to be going back to building thinking classrooms. We're just taking a small interlude to talk about vectors. Stooky, good evening and welcome. No, that's sort of a pseudo-spoonerism of my name, so. Bit forward to the A inverse matrix? Yeah, probably not. At the moment. So anyway, when we're doing vectors, we're looking at directed segments and representing magnitude and direction. Now, how do we do magnitudes and directions? Well, typically,
Chase is the digital bank you can rely on with helpful 24/7 customer service.
magnitude's pretty easy because if you notice,
Even when you're on
right,
holiday
whoa,
and it's the middle of the night back home,
let's back that one up.
get a handy 1% cashback on everyday transport.
Like on the train to visit family this summer.
Here we go.
That, join millions of customers and see
Turn down the sloppiness on that one. Whew.
Search Chase.
All right.
Plus you
So
can
here, again, if this was a 5,
groceries, everyday transport and fuel for your first year, max 15
no, it
pounds a
wasn't,
month.
4-7. I'm the one who's doing this, I should know. Right, if we're doing this as 4 in this direction and 7 in this direction, these directions are orthogonal to each other. So that means that they meet at a right angle. And if they meet at a right angle, hey, guess what? We know that this side here is 4. We know that this side here is 7. So what's the magnitude? What's the size of the third side of the triangle? Oh, look at that. It's a hypotenuse. What's the size of a hypotenuse? We know how to do that. All right, this is going to be c squared, or oftentimes we could call it like, you know, vector. Let's call it, if we call this a vector, the double lines on either side mean that we're going to be taking the magnitude of this particular vector. And so this magnitude is going to be equal to the square root of, just the same as what we do here. This is our a squared plus b squared. Here, this is going to be our, if we have this as a x hat plus b y hat, then it's the same thing. That might be slightly confusing. It's fine. A squared plus b squared. Let's change that to c, just to save everybody's sanity. Right, the c vector has a magnitude of square root of a squared plus b squared. That's it. And we're not going to deal with metric tensor spaces, so no. No. Some of you are chomping at the bit. Can feel it from this side of the screen. Okay, so the magnitude of the c vector is going to be the square root of 4 squared plus 7 squared, which is going to be 16 plus 49, which is going to be 65. Square rooted. And that's 13 and 5, so we're not getting anything out of that. Nice. Okay. Now, here's the last little bit. How much have you done of trigonometry? Come on, Twitch. Yeah, that's fair, right? Sine, cosine, and tangent. So you have done basic right triangle trigonometry, which is really easy in order to figure this stuff out. That's all you really need. Note, right, what do we have? What are the two things that we started with? Well, we started with the x direction and the y direction, and we want to know what angle this has away from our 0 angle. So if this were completely flat, it would be going that away. What we want is to know what that angle theta is going to be, and then you look at the two sides that we have available, and that uses what trig function? Think about which sides we have compared to which sides we're going to... Thank you, Filter. Compared to which angle it is we're talking about. So, within the right triangle, we have the not right angle is going to be, usually the one at the origin is going to be the most important one to look at. So again, what we're really doing is we're saying, okay, relative to your boat, right? What's our heading? Where are we actually facing on a compass? Now, I will say that when you're normally doing this, in trig, we start with a 0-degree angle off to the right, and then increase as we go counterclockwise. When you pull out a compass, it's not. Right? It starts at 0 and then starts increasing clockwise. So, like, we have not reconciled this, but it makes complete sense in the two different modes. You just have to think about it a little bit. So when we're talking about direction, what we're going to be doing mathematically is starting from 0 degrees and increasing as we move in the counterclockwise direction. So 90, 180, 270, all the way around to 360. Excuse me. When you're talking about heading, right, we start with 0 degrees north, and then 90 degrees, which is east, 180 is south, and 270 is west. Again, we're going in the complete opposite direction here, so you have to think about it in terms of context. So direction, we're talking vectors, and math specifically. Again, we're moving in a counterclockwise direction, whereas heading, when you're talking about a compass on a map, you're going in a clockwise direction. It's going to mess you up unless you, like, compartmentalize, basically. But if you've done any orienteering, if you're, do scouts or whatever, you'll learn it pretty quick. So this is fine. It just takes a little bit of getting used to. Okay, so when we're doing direction vectors in math, we want to know what this angle theta is going to be based on these things. And yes, the tangent of that particular theta is going to be equal to 7/4, opposite over adjacent. The opposite being the one that is the angle is opening up to, and the adjacent being one of the legs of that angle. Now, if you want a much deeper treatise on this, you can go see any of my in my YouTube playlist. There is a whole thing on trigonometry, so if you look for any specific one that talks about trigonometry and like the origins of trigonometry and how to start trigonometry, or the unit circle, right? That's going to start from the beginning of this. And it'll give you a much better sense of how to actually make it work. For here, yeah, sometime. For here, what you're going to do is we're going to say what we need, if you remember from Algebra 2, is a function which undoes or uncovers our theta. So here, this is the inverse tangent, or the arc tangent, of both sides, which then says that the inverse tangent of the tangent undoes each other. So this is going to end up with theta, asterisk, we'll worry about that later, is equal to the inverse tangent of 7/4. Now, why is it an asterisk? Well, that's not the only angle which gets you a 7 and a 4. It's the only one that gets you A7 and A4 in that order with those signs. However, the ratio of 7 to 4 happens twice. Where are you looking? RQ? So if we do inverse tangent of 7/4, we end up with this is 1.05165. This is in radians, which you probably don't want to or need to know that at the moment. I talk more about it in the trig thing. In degrees, this is going to be 60.255. Oh, you did do radians. Oh, good. So you can get either of those two answers. Oh, good. Right, somewhere about 1.05 radians, which is about 60.26 degrees. So then when we're talking about the vector, right, our c vector, which was 4x hat plus 7y hat, we could also say that it is, this is where it's going to be a little messed up. You probably haven't done the polar form of it. But this is the square root of 65 times, yeah, cosine of 60.26 degrees. Plus, this is mean of me to do, so sorry. You know what? Let's break it up. This is x hat. No, this is not. No. Never mind. Oftentimes this is given as r comma theta as another possible way of expressing the vector. So like 60.25, or no, 60.5 65 square rooted, comma, 60.26 degrees. So you may end up seeing something like this when you do it in polar form. This is Cartesian, invented by René Descartes, or at the very least properly introduced and formalized by René Descartes, French mathematician who spent his time in France until the Queen of Sweden decided that she wanted him to come and be her private tutor, at which point he was used to staying in bed, lounging and doing mathematics until basically like noon, and then just relaxing most of the day and still doing his mathematics and stuff like that, and then going to bed pretty early and then waking up again whenever he felt like it. The Queen, on the other hand, was like, no, I need to learn math, and you need to be in, in chambers or wherever, ready to teach me at 8 a.m. And he was like, you what? It was not long after this, he ended up catching a nasty virus, probably pneumonia or something like that, and ended up dying. So hey, body routine is important. Set a routine and try to stick with it as much as you can. When you change your routine, things are going to get messed up. You're probably going to be okay, but ease into it. Okay, ads are about to start, so we'll come back. If you do have any more questions, Waffle Lover, feel free and ask. And if anybody else has any other questions, we'll work on them. And then we're also going to head back to Building Thinking Classrooms in just a couple of minutes after break. So, check that out. Yep, no worries. These are the 7 previous things we were working on. So if anybody hasn't seen these yet, this is a good start. Be back in 3.
This week on Morrison's Market Street, Our weekly specials are full of British showstoppers. Save a third on British pork shoulder, now £3.66 a kilo. And British beef brisket, now £10 a kilo. Go on, treat yourself to a flavour-packed dinner that feels fancy, but doesn't cost the earth. Fresh from Market Street. Majority of stores, excludes Morrison's Daily. Online may vary. Pork shoulder was £5.50 per kilo, brisket was £15 per kilo, ends 21st of September.
Summer's here, and so are our great last-minute getaways. Book a Jet2 holiday for this summer. From timeless Turkey to stunning Spain, you can now fly to over 60 destinations, direct from Manchester Airport. There are loads of free Child Place holidays still available. And as always, you'll get 22 kilograms of baggage included. Jet2 Holidays. Package holidays you can trust. Aptronaut or protected. Subject to availability and conditions.
Right. So hey, welcome back. We will just real quick. Redeem a good form. So we have not been doing much in the way of Tai Chi lately, except here on stream on Tuesdays. So we'll do another form in Tai Chi. We'll do both of them that I know. Alright, so the basic warm-up here is to kind of use your weight to rock back and forth and to set your arms in motion, trying not to actually do anything with them. So don't try and maybe guide them a little bit, but don't try and like whip them back and forth or anything. You're just basically using your own motion to set them rocking like swings. So we come down a little bit, and while our arms are swinging forward, and that adds a little bit of speed to it, and then we rock back up, and that sends them upward with extra energy, just like, again, when you're on a swing. Change sides. It doesn't really matter which side you're on while you're doing this, because it's going to be the same. Mostly that's just for whether or not you can get your weight shifted on your legs pretty evenly and balanced. And we usually come from here. No. Same deal here. On the downswing in the front, just bend knees a little bit and send your arms flying while you're twisting a little bit. This actually becomes important as you're trying to expend your energy to stop, people from swinging at you and things like that. All right. Now we move to bear, which is always fun. So let yourself come out like a bear. And then what we do is we turn to one side where most of our weight is, and then we back up onto the other one, turn, and back up onto the other leg. So what we're trying to do is keep our butt no further than about halfway down our calf. That ensures that we have control over our body. And essentially what you want to do is when you're transferring weight, you want it to be like sort of seamless. You don't want to evenly distribute your weight and then shift it to the other side. Although that does happen, right? Intermediate value theorem. What we want to do here is effectively push so that we end up with almost all of our weight on the back foot immediately, or almost immediately, and the front foot is just pushing out away from us to get us to transfer our weight over. And then we continue. Also gets you in a nice breathing rhythm most of the time. All right. So from here, the actual Tai Chi thing that we're supposed to do is have our front leg in front of us, just slightly off from, like, we don't want it to be in line, unlike my karate. We want it to be more or less off like this. We want most of our weight to be on the back leg. Again, we want our butt not to be more than, or like further back than halfway down our calf. And reason being, this allows us to push downward into the floor with both our front foot and our back foot, mostly the heel in the back and the toes in the front. And that allows us to do this thing which is called like double weighting. So you're not quite pushing twice as much body weight down, but it feels heavy. And this also absorbs a huge amount of energy into your back leg. If someone were to push you, you want to basically be able to absorb that into your back leg and then be able to snap forward as you need to. So we end up with, again, most of our weight's on our back foot. And then from here, we push down. And then if I just lift my front leg, I'm going to automatically spring forward with my back leg and come off of it like that. This is not your grandmother's Tai Chi in the park. All right, I do, however, need to take the socks off because I can't feel the floor very well. So, again, weight mostly on the back foot, double weight, and then that allows us to come forward anytime that we want to by springing off of the back leg. Okay. So the form starts with feet pointing parallel to the front, and we raise our arms in front of us. Ball of energy to the left. Ward off to the right. Roll back. Press. Push. Pluck. Split. Elbow. Shoulder. This took like 3 weeks to get the whole thing right. He was like, these are a lot of complicated movements. Now I can do it in like 30 seconds. It's fine. Academy of Useless Ideas. Good evening and welcome. Anybody who doesn't know me, my name is Obi-Wan Pez. This is N Simplex Pachinko, and right now we're doing a little bit of a Tai Chi break. So, one more time. The basic form goes, breathe in. Breathe out. Ball of energy to the left. Ward off to the right. Roll back. Press. Push. Pluck. Split. Elbow. Shoulder. And from that, we can just go immediately to ward off. Roll back. Press. Push. Pluck. Split. Elbow. Shoulder. The idea is that you keep doing that all the way across the room. And then you run out of space eventually. Alright, and then if I can remember it... The idea is that that uses all 4 orthogonal directions, as well as the 4 diagonal directions, to use all 8 of the movements. The first 4 are used when you are in control of the situation. And the last 4 are when you don't have control of the situation. So for instance, somebody's coming at you, and it's not just like, I could just roll. So if I do roll back and go like that, I can usually grab somebody's arm and just move it out of the way and parry. Well, if they're coming at you faster or at a different angle or something like that, you can instead pluck. So you grab their wrist and essentially move out of the way and put them where you were standing. And then split. And that is, again, either a just straight slap to the face, box the ears, or my favorite, ridge hand. Right? They try and grab you. What do? Well, you strip them off, grab something, or like the back of their neck, and elbow. And then that doesn't really work. We sink back, and then shoulder. When you drop that shoulder into a soft area in here, it does a lot of damage, because I am approximately 200 pounds. That's a lot of energy. The second one is a sort of dance that you can do with a partner. So basically, we're coming in with a split, only this one, instead of coming sideways, is coming over the top. And this is sort of like tiger paw. That person is then going to roll back and... roll back and split. And then step out of the way and do their own split this way. Or no, pluck. Roll back, pluck, split. And I think ward off from there. So I can't remember exactly what the 100% what the order is, but you end up doing, again, split. Yup. Oh, man. See, it's been over a month now, so... And we only did this, like, a dozen times. I'm gonna have to watch my old videos and make this happen. But essentially, from here, it's like, let's see, can we roll back this way? That's not it. Come at it like this. He tries to take me into an armbar. I reinforce and step into it so that there's no way that he can actually bend my arm that way. Once I've stepped here, I can then pluck and step up and split. I think that's what it is. More or less. So it's a... There must be a ward-off in there, but it's really... You're usually like right tight up against the person, so your forearms are like this when you're doing this. He tries to take me this way, I reinforce, step in, step up, and I'm not going to remember it, it's fine. I'll just look it up later. Hey, Stookie! Oh. The sounds from the elbow. Yeah. Good times. Alright, so anyway, let's get us back over to Math Night. It's just all this skin-on-skin slapping. I don't know what's going on. My. Alright. Okay, so we were talking about building thinking classrooms. Chapter 8 is all about fostering autonomy. The previous 7 were to start with a non-curricular thinking task, split the students into visibly random groups of 3, stand them at vertical non-permanent surfaces, defront the classroom, so do not give a front to your classroom. Have it be, obviously, this is the front of my office, yes? But if I spent all of my time back there, there wouldn't necessarily be a front particularly, especially if I was also facing other directions for almost equal amounts of time. Give your tasks standing, loosely clustered around you, verbally, and within the first 5 minutes of addressing the whole class. Answer only keep thinking questions. If any stop thinking questions come, you just kind of smile, nod, shrug, and move on. Don't even give them the time of day if it's a question that you're not, like, going to encourage them to ask. And switch the language around homework to being check your understanding. So these are not marked, not even referred to, not, hey, take this out if you've got it. No, don't do that. Answers are given immediately upon assignment, whereas the full solutions follow a day or two later. So the problem that can arise from this is that it requires greater student ownership and autonomy. There is less teacher control, and anybody who's a control freak like me, you're going to feel some hurting here. It's going to be a painful transition, and it's okay, because there are other contingencies. Again, outwardly, traditional classes look ordered. The students seemingly are all engaged, but typically they're only fulfilling the social role of student. Okay. It's like the third time we've said this. It's fine. We keep finding new people. Thank you so much for coming, everybody. Okay. So, lack of autonomy is synonymous with lack of choice, and lack of choice reduces the need for students to think. Naturally. Again, we're reading Peter Liljedahl's most of his words here, and then I'm interjecting. This amount of thinking, the amount of thinking students were required, the amount of thinking students were required to do and did was sharply reduced in situations where their actions were managed and even micromanaged by a teacher. In thinking classrooms, students' actions cannot be managed the same way as a typical classroom. When students were working in random groups on vertical non-permanent surfaces, you typically can only work with one group at a time. This means that any moment there are 8 to 10 groups that need to be working independently. There's much happening that is outside of your control, and in order for that all to work well, students need to take on much more responsibility for their own learning. Interesting in a community college setting. Again, most of the time this is K through 12, as it says right there. But I was at the American Mathematical Association for 2-year colleges, national conference, or American conference, which was in Toronto, because North America, right? And we did all sorts of, or we were listening to a keynote, but he gave us all sorts of information on how to make this work, and how it worked in elementary and middle and high schools, and so it should also work at the community college setting if we extend it a little bit further, if we do some thinking about it, and if we get some feedback for ourselves. And again, for the most part, I think it worked. My students were certainly doing more thinking. That does not necessarily mean that their grades were better, but we'll discuss that later. Okay. So this taking on more responsibility for their learning cannot happen unless the autonomy to do so is there. The question is, exactly what should they have autonomy over, and how are you fostering this? So really, this is the major question for the evening. What do students have autonomy over, and how are you fostering it? Early in the research into building thinking classrooms, it became apparent that every teacher implemented the thinking classroom practices slightly differently. Shocker, I know. Whereas some teachers used cards to randomize their students, others would use a computer app. While some teachers had students working on whiteboards, others had them working on windows or tables standing on end. So that's also interesting. If you just literally take a table and tip it up against a wall or something like that, that could be your whiteboard. You do have to make sure it's cleaned properly, because believe me, the cleaning people are not happy about it if you leave like schmutz all over the glass. or all over a tabletop, or what have you. They were very upset with me. To the point where they actually tied off some of the blind pulls. So they put it all the way down so the blinds were covering all of the windows, and then put knots in them all the way at the top, because they didn't want to clean. Where some teachers gave class time for check your understanding questions, others asked for them to be done at home, and so on. This was totally okay. These practices are meant to be thought of as a framework, much more than overly prescriptive set of pedagogical moves that must be adhered to. right? So takeaway, right? Teachers likewise have autonomy over the implementation of these building thinking classrooms practices. So they can do whatever they want. They can end up doing things differently than somebody else. They could do like not do some of these practices at all. That's fine. Peter found that when they're implemented all together, all 14 of them in, loosely the same way, then we end up with typically better outcomes overall. As mentioned in the introduction, the Building Thinking Classrooms framework is a collection of empirical results that offer teachers a chance to fundamentally change the way students experience mathematics. And the other key takeaway for like all of this was basically you just have to get them off balance and keep them off balance. They can't be thinking like, oh, it's another one of these classes. I don't have to do something. Nope, change it. Okay. An individual teacher may may not wish to, or be able to implement each practice in the exact way that the research has showed was best. Even if they do, they have to find a way to personalize it and make it their own. Anybody who's ever done DMing for, Dungeons and Dragons or anything like that, right? You've got to make it tailored to your group, whatever it is. You can't just be like, here's what's written in the book, because it doesn't feel organic. It feels like you're trying to force it. And every time you try to force something on these students in terms of like their pedagogical understanding, in terms of content understanding, in terms of all this stuff, it doesn't work. It fails in some minute little way that they're going to notice. And as soon as they notice it, believe me, they're going to be like, oh, I can capitalize on this. Because again, this is how they were raised, right? Try to game the system, get the best grade possible, do the least amount of work. You have to change the culture of the classroom first. And in order to do that, make it organic. Make it your own. Okay. Peter says, for me, the differences I was seeing from room to room were fascinating, and I wanted to learn more from them. One of the biggest differences was how many students' hands were raised and how often. In some classes, many students had their hands up every time they were done with a question or whenever they got stuck. We talked about this in one of the earlier sections. In other classes, I saw no hands go up. Yet these students seem to progress just as far and sometimes even farther than those in classes where the teacher was providing a lot of individualized help. To be clear, this research, the autonomy research, was done before the research on how to or not to answer questions. So eventually these practices were brought together, but it wasn't done as like a single piece of research. It was done as multiple sections. So he was trying to stage these things, go this one next, and then this one next, and then this one next, and then bring these practices together in different combinations. When I began to pay closer attention to the classes where students rarely, if at all, put up their hands, I began to notice that there was much more interaction between groups.
Chase is the digital bank you can rely on with helpful 24/7 customer service.
So I can speak to a real person anytime.
Of course, even when you're on
So taking those last couple statements together, more interaction between the groups seems to have led to fewer questions to the instructor and had no negative outcome to progression. That seems like a win-win. And this interaction was both passive where they were looking at others' work. Keeping in mind, they're at vertical, non-permanent surfaces, so white and black boards, and or, right, they put their best work kind of at the top. So, key takeaways from stuff they will then copy up high and then erase stuff down low. Maybe that was borne out in the research rather than something that he initially noticed, but nonetheless. So this came in two flavors. Again, passive, looking at others' work, and active, where they actually physically went over and asked them about their work. Further, I noticed that these interactions occurred most often at moments when a group was either finished or stuck. Again, kind of two flavors on this. Most often when finished or stuck. That is, when a group was finished with their current task, they would look around the room first to confirm their answer. And then look for another question that some other group was working on that they hadn't solved yet. So this broke up into two major behaviors. When they were finished, they would confirm their answer and then seek out new problems. All by themselves. They would just go ahead and do it. Again, these classrooms had their cultures changed at this point. It was no longer about doing the work in order to get a grade or looking good to the teacher. This was actually starting to get into what we'll talk about later, getting into that flow state where you're just like, yeah, let's keep it rolling. Let's go. If in their efforts to confirm the answer they saw something that was conflicting, then they would either take this as a cue to dive back into their own work or actually go talk with the group to figure out what happened. Right? So confirming your answer was mostly passive. And then it turns to active if it's conflicting with somebody else. And again, seeking out new problems, generally passive. And then that could also lead to them getting stuck if that particular problem that they were looking at was something that was maybe a little bit above where they should have been. I use should have pretty lightly here. We'll talk more about that. I think that's next week. Yes, using hints and extensions. So we'll talk about that next week. In terms of like, what do I mean by where a group should be? Because that's an interesting dialogue to be had. If students were stuck, they would behave in much the same way and either look passively around to see if any of the work that they could see would inspire them, with some idea of how to proceed, or hint at what they might be doing wrong. Often these passive looks resulted in borrowing notation. And or some sort of organizational tool like tables, graphs, diagrams, etc. Right? These students were not just copying answers from other people. When I did it, I had not quite adequately shifted the culture of the classroom. So a lot of students were still trying to make themselves look good in front of me. They were doing it for purely aesthetic and cultural reasons. They wanted to appear to be good students, not necessarily looking to do the work to get them to where they needed to be. Right? So that was my main problem. The culture was not quite shifted yet. And sometimes it would prompt a more active interaction in the form of a conversation with another group. Right? And then again, all of this can lead to the active learning, active interaction with other groups of having conversations about what's on the board, about why they chose to do something. It varied every single interaction. No surprise there either. It was clear from all of these interactions, both passive and active, that in these classrooms, knowledge moved easily from group to group, and this made the work of the teacher much easier. So, this is the key takeaway for this one, is that we have the mobilization of knowledge. Getting information from one group to another is the most important thing that you can do as a teacher. So don't worry too much about trying to speak specifically with one group and say, you guys, I need you to do this. Hey, you guys over here, you're kind of straying off the path. Why don't you come back a little bit, like go back a few steps? You don't need to do that. Oop. Right? It is easier for the teacher than micromanaging all of their moves and processes, saying that you need to go do this, that, and the other thing. No. Get them to speak with those guys over there. With that group over there. Hey, did you talk with them? Right? Keep an eye on what everybody's doing, just like they should be doing. And then if you see somebody who is in a particular place that needs to be unstuck, that needs to be guided or whatever else, then you can send that group or one person from that group to go talk with that group over there. Most of the time you can send the whole group. They'll talk with them. They'll have about a 30-second conversation and they come back. The more independent and responsible the students were in managing their own learning, the more focused time the teacher had to spend with the groups that actually needed their attention. It was also clear that this independence was a product of the autonomy the students were given to both passively and actively interact with other groups and their ideas within the room to mobilize the knowledge within the room itself. This is not to say that students had total freedom to do anything that they wanted. If students from different groups were meeting up to discuss something not related to mathematics, the teachers were quick to get them back on track. The same was true if the teacher saw students using their cell phones for any non-mathematical type stuff. I know in my class, they use Desmos all the time. How do you know that they're using Desmos and not something else? Well, you do what you can. But I can't help it if somebody's off sitting on Snapchat or something like that. I will, when I get into the classroom and it's my students who are off doing whatever, I can say to them, hey, I don't even need to talk to them. I can talk to one of their other people and be like, hey, gonna be his turn to write. I can make suggestions rather than saying you need to get on task. I can let it be up to the groups. Hey, why don't you involve this person? The autonomy the students were afforded was specific to the knowledge mobility. So if you need help, get it. If you need another question to work on, find it. This was clearly important and, therefore, became one of the practices identified as being needed for building thinking classrooms. Ironically, when I mentioned autonomy to the teachers, who had many students who frequently put up all their hands, all of them said that they do give their students the autonomy to look around and interact with other groups, and they often tell their students that it's okay to do so, get involved. I even watched 3 of these teachers do just that with no effect whatsoever. So what happened in those classrooms? Right? What happened in this particular case? In these 3 particular cases. So, I went back to the teachers whose students were not only given autonomy, but also used that autonomy to keep themselves moving forward through passive and active interactions. Even closer inspection of what the teachers did in those classrooms revealed that they themselves frequently made use of the knowledge in the room to help move the groups forward. That is, rather than directly answer questions, give help, or give the next question, they would sometimes direct a group's attention to what another group was doing. That's what I had said earlier. Right? Instead of answering the question, instead of you being the source of knowledge, tell them to get it somewhere else. Politely. Okay, so conversation between a teacher and a group. So where are you at with this? I think we're stuck. We're just going around and around in circles. Huh. Why don't you look at how Group 3 has organized their data? It might help. Hey, what's going on? You guys are just standing here. We're done. What's next? Why don't you ask Group 8, which is the group right next to them? They seem to be working on something different, like something you haven't done. Now, in this particular case, we talk about in Chapter 9, you do need to give them something that's appropriate to their challenge level and their abilities. So you have to kind of figure out where it is that this group is and what their next step should be. Do you think that that question right next to them is at an appropriate level? Does it need to be a little bit harder? So you raise the challenge level. Or does it need like another gradation? So you can give them a question that's just one down from that. If, for instance, the group doesn't quite understand what is going on for this question. One example is when you've got quadratic equations and you're trying to factor them, right? Your pluses and minuses in each place tell you something about the whole problem altogether. These types of moves were seen much less frequently in the classrooms where students put up their hands often. In those settings, the teacher was much more likely to suggest using a table or giving them the next question themselves. So again, if you've got a student, a group who needs a brand new question, so they're at like the front edge of the class in progression, then you will have to give them the next question. Or you will have to come up with a question based on what they already have on the board. Hey, what if that last sign were negative? That sort of thing. Eventually, if you've done it right, those students will, later on in the semester, ask themselves that question, rather than you needing to direct their attention to it. What would happen if these signs were different than they are now? Well, what are the 4 different combinations that we could have for a quadratic having these 2 signs be positives and negatives? Okay, now we got to add a negative on the front of this. So for A, what does that do? Well, that doubles all of our possibilities. So now we've got 8 different possibilities. These deflective moves became something we began to experiment with. Working with teachers from K through 12, we began having the teachers direct students to other groups whenever they were in need, or in need of a new question, or getting stuck. In short, rather than being the source of knowledge in the room, teachers were there to mobilize the knowledge that was already there. Right? The mobilization of knowledge that is already there in the room. There's probably somebody who already knows how to do whatever it is you're working on, or has a very good idea, even if they don't have any clue. They've never done this before. Somebody might have a really good idea, so you kind of tip the scale and tell them, go see what that person's working on. See if that inspires you at all. That is, to restate, the teachers were being deliberately less helpful. Right? The teachers with the best results were being intentionally less helpful. And it worked. It paid off. This proved to be extremely effective at getting students to seize autonomy that they had been given and begin to use it to keep themselves moving forward. After the first 2-week cycle, we saw huge improvements in this regard, and after a second 2-week cycle, the classrooms were, for the most part, functioning the way we wanted them to. Fewer hands in the air, more passive and active interaction between groups, less interaction with the teacher. Less demands on the teacher's time. So now the teacher can individually go to the people whom they see as needing help. In the second cycle, we also began to mobilize knowledge even before the groups were stuck or in need of a new question. The most obvious time to do this was when 2 or more groups had different answers. Getting these groups to talk to each other without specifying what was correct and what was not, or, sometimes both wrong, proved to be very effective and deepened students' thinking. Hey, so that group over there has 45 as their answer, and that group over there has 51 as their answer. I can guarantee you that at least one of these groups is incorrect. But I'm willing to bet that there are parts of both of your answers that you agree on. Start talking about what you agree on, and then talk about the parts that you don't. Go. The same was true when the groups had the same answers, but different ways, different methods of approach. So I see that both of you have the same answer here and here, but you did it in completely different ways. I would like each of your groups to try to figure out what the other group was thinking. What's the process? Is it sound logically? Does it make sense to you? Purposefully mobilizing knowledge by forcing either passive or active interaction between the groups activated the autonomy the students have been given, increased independence, deepened thinking, increased the porosity between the groups that was started with the random groupings discussed in Chapter 2. Right? You've already got this in the randomization, but now the porosity of the groups just being freely moving between each other and chatting all the time whenever you need some sort of, again, either help or an extra challenge or anything like that. Discuss with another group. What is it that you need? You can move between the groups, you can chat a little bit, and then you come back. You share your knowledge with everybody at your individual group. Activating their autonomy also had an effect on how students thought about their work and their workspace. First, the group stopped trying to shield their work from everybody else and saying they're cheating. On the other hand, students were much more likely to look around without feeling themselves like they were cheating. There was an increased sense that they all had something to offer everybody else, and that other people had a lot to offer them too. Group 1, the teacher sent us over to here to see what you guys are doing. Group 2, that must mean that one of us has something to share. Is it you guys or us? Autonomy, like any room organization, was not something that I began my research thinking about as an independent variable in need of research, but as it did with classroom organization, spending time in the classrooms and experimenting with these practices that increase thinking revealed that autonomy is a variable that needs attention. A thinking classroom is a classroom where students think individually and collectively. The collective goes well beyond the limits of the group boundaries and encompasses the whole class. We need to give groups the autonomy to make use of the knowledge in the room. But this, it turned out, was not enough. We also needed to help them break down the barriers around their individual groups by mobilizing the knowledge in the room for them. Not only does this build the independence that is needed for thinking classroom to function well, but also engenders the type of 21st century skills that people need to work and collaborate in the real world. All right, so we're gonna go to ad break in 20 seconds here, and then we will come back and do the FAQ, the macro and micro moves, and some questions to think about, as well as some of the thinking tasks. So see you in another 3 minutes. Be right back. Thanks for coming.
Chase is the digital bank you can rely on with helpful 24/7 customer service.
So I can speak to a real person anytime.
Absolutely, even after work. And you get a handy 1% cashback on everyday transport.
Like on my bus fare when I'm heading to that festival.
Roger that. Join millions of customers and see what your money can do with Chase. Search Chase Bank. 18 plus UK residents. Eligibility applies. 1% cashback on debit card spending on groceries, everyday transport and fuel for your first year. Max £15 per month. Exceptions apply.
Welcome back, everybody, for the last little bit. So, on the FAQ. So does this mean I should stop answering all questions? Answer, no. But if you want your students to begin to seize the autonomy you have given them, then look for moments where a group can get what they need from another group instead. When you find such a moment, the key is not to say or show something that another group can. So only answer the questions yourself that no other group could give them. If I give and foster this kind of autonomy, won't some groups just begin to copy from others? So as mentioned in Chapter 2 and 3, this actually turns out to be a very rare occurrence. In the hundreds of times I've been in a thinking classroom, I have never seen a group copying line by line from another group. By and large, when a group looks at another vertical surface, they do so for hints. These hints often take the form of notation, organization, or key ideas. Once they have acquired that, they go back and solve the problem for themselves. Or they're looking for validation so that they can feel confident to move on. Eventually, students start to look for other groups for extension. They look to other groups for extensions. In short, the groups look for things that you would feel comfortable giving them if you were to help them. So, ideally, right, they are getting from other groups what they would have gotten from you anyway. That's more or less what we said in the first question, too. Is there ever a time where I would want a group to work entirely on their own without any hints from any other group in the room? There are two instances for which you may want this. The first is if you ever wanted students to answer some check their understanding questions where you want them to really see whether they understand what they're capable of doing entirely on their own. The second we'll see in Chapter 14 when we discuss the possibility of doing group quizzes. In neither of these instances is it necessary that groups work without interactions with other groups. But if you wish for this to be the case, you can give every group a different question. This is more taxing on you, but it achieves what you're looking for. I had a thought. It's probably gone now. Yep, completely gone. Oh, there we go. Yep. I want to put up Peter's book. So just as a reminder, this is Peter Liljedahl's book. It is at Corwin Publishing, and I do not recommend that you purchase this unless you are an educator, you know someone who is an educator and is looking for a different method to use, or you have like some genuine interest in mathematics education. perhaps some other subjects education as well. But again, for the most part, do not purchase this book if you're just like randomly here. That would be quite ridiculous. I'm sure Peter would be very happy to sign it if you ever met him. Is it helpful to put two groups together that have the same strategies or the same solutions? Yes. Every group develops their own way of talking about a problem and their own way of representing it. This is why when you put two groups together, one of the first things they do is negotiate a language and a notation. So even if you put two groups together who have seemingly similar solutions, these negotiations will strengthen their understanding of the solution and their ability to communicate. How can I tell whether groups are actively interacting for the purpose of mobilizing knowledge or just socializing? The short answer is listen to them. However, if you're not close enough to listen, there are a few visual cues you can attend to. First, if one member of the group is talking to only one member of another group, there's a strong chance they're socializing. If both groups have backed away from the vertical surfaces and no one is gesturing toward the vertical surfaces, there's also a strong chance that they're socializing. However, keep in mind, I have seen both of these occur, and the discussion was 100% about the mathematics that was on the board. And the problem at hand. Also keep in mind that when two groups first begin to actively interact, they may begin the interaction by joking around and talking about things that are off topic. Everybody does this anyway, right? We negotiate the language, you negotiate, you see where people are, you check their personalities, that kind of thing. If this does, if it goes on for too long, you need to intervene to get them back on task. All right, so now that everybody's gotten to know each other, how about we get back onto the math? If one group is helping another group, how do I know they're helping and not just telling them how to do it? Again, this is something that you negotiate toward the beginning of the semester. You try to get them to shift the culture. This is not about completion. This is about understanding. If a group thinks they understand it, check them. Spot check them. Great. Can you explain this to me? You, specifically, explain this to me. Can the three of you negotiate together to explain this to me? But, for the most part, Peter says, it doesn't matter. Regardless of how a group acquires the new knowledge, they tend to take that knowledge and try to apply it for themselves. Even if they don't, the extension that they're next asked to work on often requires them to apply the new knowledge anyway. Having said that, it's always best if groups who are in the helping role are thoughtful about how they give out ideas as to maximize the opportunity for learning, for the learning group to think for themselves. You may wish to discuss with your class from time to time, but not until after you begin to mobilize the knowledge to begin with. What if the help that a group actively gives or a group passively gets is mathematically incorrect? Okay, happens from time to time. But in the collaborative setting of a thinking classroom, groups tend to self-correct. After all, the more eyes that are on something, the less likely an error goes unnoticed. This is how real math works too, right? For this reason, mobilized knowledge, like collaboration, also tends to converge toward correctness. And do not forget that you are still in the room and monitoring the progress of everybody in it. If you see an error, you can point it out. But probably, you don't want to be too blatant about it. some of the scripts that were mentioned earlier do kind of help toward that. Okay, I see that, you two groups have two different answers. So let's discuss. Why is it that you have two different answers? That does mean that at least one of you is wrong. Okay. So. The macro move for this time around is to mobilize the knowledge, specifically mobilize the knowledge that already exists in the classroom. And the micro moves. Model passive interactions. So, hey, do you see what they're doing? What do you think? So, help groups to see what others are doing. So, model passive interactions. All right, model active interactions. Right, suggest with whom to speak. So, hey, have you checked out this group over here? What do you think about their stuff? Why don't you talk with them and figure out what your next step's going to be? Model passive interactions by here, help groups to see what others are doing. So help them look around the room, find those things for themselves. Deliberately be less helpful. I gotta tell you, that was my favorite one. Lastly, don't say or do anything that could be said or done by another group. Right? So again, the front edge of the progression, obviously you're going to have to lead them by just giving them the next question that's in your list, appropriate to their progression individually. But as soon as they've got it, now you can encourage the next group that needs that question to go get that question. Okay, so the standard questions apply here. Peter almost always asks this as question number 1. What are some of the things in this chapter that immediately feel correct? So first off, right, the mobilization of knowledge, getting students to spread that information by themselves and then double check each other's work is something that you want in a professional setting. You want to make sure that everybody else is just, quick spot checking to make sure that everybody's doing good work. And if you got a different answer than somebody else, then you better figure out exactly why you got a different answer than everybody else, or than the other group. Right? Most knowledge at this level is already here. Whether that's because somebody read ahead in the book, awesome job, 10 out of 10, no notes, or somebody's seen it before, or it's led up to from all the previous stuff. Right? They are either they have the knowledge or they're ready for the next step to be able to make that jump to say, here's what's next. I get it. Most of that knowledge at this level, specifically, algebra, trig, all the high school math, college level math, first couple of years, that knowledge is all already here. No, I shouldn't say all, right? Mostly. Most of that knowledge is already here. Have you already given your students autonomy to interact across groups? So prior to this, I didn't really have groups, right? My original style was Socratic, so I would just stand at the front and then write stuff as people got to it, as people had ideas. We take all sorts of wrong turns and do all sorts of fun stuff. Did they take advantage of this autonomy? So, somewhat. The students who got it, right, were able to then run with it a little bit and say, well, let's follow this line of thought. And we get to working essentially it would be a group of 3, me and 2 other students who actually were seriously locked in and paying attention. The rest of them, yeah, I wish they would step up a little bit. But once we started switching to building thinking classrooms, things were already immediately much better in terms of getting everybody involved and start chatting across groups. It didn't take much for me to do that. It did take a little bit of time to fix the culture and get them to see, okay, I'm not just screwing around with my friends. I'm actually here to work. Let's do this. What are some other ways you might foster autonomy besides what's mentioned in this chapter? If students have the ability to seek out questions, so they might find an application problem somewhere, right? Tell them at the end of the lesson, go find an application problem that's not in your book. That's just not on a math site. Go figure out see if you can find a problem in the real world that mirrors what we've got going on here. This chapter focused on the nurturing of independence through fostering of autonomy. Have you found any other ways to nurture independence? Again, trying to get the people in the groups to work together to figure out something. Will foster some independence from the teacher. They still might feel dependent upon each other. It depends on their individual abilities and comfort, all that. What's your feeling about mobilized knowledge versus groups doing the work on their own? Groups doing their work on their own is great until somebody gets stuck. Realistically, this also starts dipping into sort of a political arena. Right? Like, everybody in society is dependent upon nearly everybody else to get stuff done. So, we need to start, like, really fostering this ability in students so that they know that they're not alone in this. They're not going to be all by themselves, or they're not going to just be in their small community. They have other resources that they can reach out to and start figuring out, who else can help them in any given situation. We want them to go out there and start seeking out additional help when they need it. And if you've got them seeking help from each other, they're not coming to the big government to do it for them. So, collectivism. What are your feelings about the possibility for proliferation of errors in a classroom where knowledge is being shared between groups? Again, Peter already addressed that. It's self-correcting, and even when it isn't, you're paying attention. So, just keep an eye on it, and let them argue a little bit about who's right, who's wrong, where some errors might exist. But at the same time, if it starts getting out of hand, you can stop everything and be like, okay, so this is what I'm seeing, and just offer some observations, which then get some of them to talk to each other, to get them to question each other, themselves, whatever. What are some challenges you anticipate you'll experience in implementing these strategies? I mean, honestly, it's just the socialization aspect, but I'm also a very non-confrontational type person. So whenever somebody's not doing what they're supposed to, most of the time I'm like, well, you're just fafoing at this point, like, whatever. I'm not going to bother because it's just going to work itself out. I need to work on that because I can't do that. That's not right. But it was also me working at a community college level where I was lecturing at the front. So, I can't stop the lecture every time somebody's starting to get off task. That's just not reasonable. In the BTC format, it is a lot easier to just say, hey, and you're not calling somebody out either, because you could, again, get the group to deal with it and be like, hey, your peer is not helping you. I think you can probably deal with that. I would tell him to get out, yeah. So that's the other thing, is that, I absolutely hated doing anything remotely like that. The problem is, you skip school a ton? So the problem with sending them out is that most of the time that's what they want in the first place. They're not there to do the work. They're there because they have to be. In many cases, right? The ones who end up getting kicked out are almost certainly there because they have to be, not because they want to be. dorks like me absolutely loved school and was like, what the fuck is your problem over here screwing around when you could be learning something? That was me. Probably why online school works, yeah. Right, and like you have the autonomy yourself to do what you need to do. I would argue that you would learn better in this format than you even do online. Which, like, bold claim, I know. But the idea here is that, again, you are now able to work as fast as you need to, both in and out of the classroom. So you would be able to still keep working if you went home and you were like, I already got this. But then when you come to class, you're then able to discuss with your peers why you think something works the way it does. And maybe it is that you could, like, you know, go through a specific process and you do the process correctly, but maybe you have no idea why it works. And then somebody else understands why it works. So now you share information and that knowledge becomes stronger. So again, when you start working individually as well as collectively, right? You're working yourself, your small group, the whole class. When all three of those are working together, it is a much more enhanced learning experience. Your online school has a Reddit group. Yeah. Try this. Thinking tasks that follow have been shown to produce diverse solutions and solution methods, ideal ground to foster autonomy through mobilizing knowledge. Yeah, no, that's true. Like, is it protected so that nobody else could just randomly start reading it? Like, only approved users or something like that? Had to put in a code at the beginning of the year? All open. Great. Great. Someone does manage it, okay. Using exactly 5 multiplex cubes, so those are the ones that usually stick together and stuff like that. How many different shapes can you make such that there is a way to place the shape on the desk and all 5 cubes touch the desk? So, one example is the easy one. Right? 5 cubes all touching each other, all touching the desk. Right? How many different shapes can you make such that you get 5 cubes all touching well, not all touching each other, but that are all touching the desk and are all connected. There we go. So, ask the students, how many can you make? they'll go off and start working on it, start thinking about it, and then potentially, I mean, I assume that each of these classes would also have these multiplex cubes. Grades 5 through 8. NDQ, standing for nickels, dimes, quarters. How many different ways? How many different ways can you break a dollar into nickels, dimes, and quarters? Now, this is really interesting here, right? You need different ways. So it doesn't work to line up 20 nickels and say the first two turn into a dime. Then the second two turn into a dime. Right? Because that's still one dime and then 18 nickels. Like, it doesn't matter what order they're in. How many different counts can you get? And grades 9 through 12. Cake. You want to arrange 4 candles on a cake. How many different ways can you place the candles such that there are no more than 2 different distances between any 2 candles? At most, 2 different distances between any 2 candles. Online school has in-person graduation ceremonies. Yep. One of them happened 4 days ago. They move around to different states. Okay, yeah. Last year it took place in your state. Yep. Yeah, I mean, makes sense, right? You don't want to. You don't want to do one in like a single location, and also you probably don't want to do one in every state, because it's just potentially could be wasteful. It all depends. It's nice they move them around, though. Okay, so that's it for tonight. If anybody does have any questions on Chapter 8 of Fostering Autonomy, let me know. If you have other questions about doing mathematics of some kind, let me know. And next week, thank you so much for the follow. Next week, we'll be doing Chapter 9, which is how we use hints and extensions in a thinking classroom. Again, mostly looking at challenge versus ability. I know that's kind of giving away most of it, but, you know. Some of you have never heard this before, and some of you have probably heard it constantly. So, again, this is Building Thinking Classrooms by Peter Liljedahl. He is, as far as I know, a professor at Simon Fraser University in British Columbia in Canada, and worked on this for 15 years with over 400 teachers to try to figure out what the exact combination of teaching practices would be to maximize student thinking. So the amount of time that they spend on thinking and the depth to which this thinking goes. There are other variables which could very well be better linear programming, better objective variables for somebody to figure out, but honestly, this is an awesome one. Again, if you are a math educator, I can highly recommend the book. If you know a math educator in your life, they may be interested in this. If you know an educator who is interested in methods, this might be interesting. But I pretty much guarantee that nobody else is going to want to necessarily have a copy of this. So I would suggest don't buy the book unless you're one of those people. Or again, if you have somebody in your life who would definitely be interested in this sort of thing. Yeah, well, you know, Christmas is coming. So, we are now more than halfway through. Man, it's nuts. Once we're done, I think probably we're going to try and keep the momentum of like Math Education Monday. I'm gonna see if I can finish reading a couple of things that I have laying around and see if I actually like focus on it for a bit. Sundays is the start of our week. We do Satisfactory Sunday. So right now we're educator, content creator. I mean, yes, but I already have one, and it's like dog-eared to hell. I love it. My daughter saw me writing this. She's like, like, it's my book. So anyway, yeah, Satisfactory Sunday. We're going to try to keep doing Math Education Monday. We are doing 9 Souls Tuesdays. Those are mostly going to be, I think, Metroidvania on Tuesday. Like that sort of genre. We'll see how long I can sustain it. I'm not really that much into Hollow Knight, but I might end up liking it more after playing 9 Souls. Wednesdays, we do like mathematics and actual calculations. So currently we're working on cracking the GRE, which is the math subject test. We'll work on stuff that goes from, we're currently on Calc 1, all the way up through topology. I do not know topology, but I'm going to try to teach myself topology based on what we have here. We also have an actual book for topology in here somewhere, so we'll see what I can do. And then on Fridays, we have In It for the Long Game, which is a game which is going to take a long time, which I know Satisfactory is also one of those. But on Sunday, we're going to kind of keep it to like base building. And then on Fridays, we're just going to do like long form games that are not base building. So we'll see how things go. This does mean that we're going to have like 5-day weeks, essentially. But yeah, I'm liking it so far. And I need to take all this stuff and put it on YouTube, which anybody who is not already following on YouTube, those are our contents. So at Obi-Wan Pez is our gaming content, and at nsimplexpachinko6542 is our math content. If you just search nsimplexpachinko, you should get me. If for some reason there's more than one that pops up, let me know, because I'll definitely want to take a look at that. And just for S's and G's, if you are at all interested in more mathematical content, we have here Zach at E to the 2i Pi, who came over earlier in a raid. We have Academy of Useless Ideas, who came over with a raid earlier. We have Walking Stick Library, who also was over here earlier and who usually is streaming about now. We'll see if they're on. We also have some of our other friends who are not currently on. Don Factorial does math and usually DayZ as some of his gaming content. Penn Center, who does a lot of Zelda type stuff and also is a department chair up in British Columbia. And Actual Education, who is Dr. Gold, who is often doing mathematical type stuff here on Twitch as well. So all these awesome people, go check them out. We also have our friends over at the Knowledge Fellowship, or TKF. They do all sorts of awesome stuff. Mr. Aegis is usually the one who is running that particular channel. However, the Knowledge Fellowship is a much larger, broader group. It is also a streaming, or what is it? Streaming group? What do you call those? It's like a guild here on Twitch. I forget what the technical name of it is. Anyway. Other members of TKF, Volcano Doc, Science Streams, Moohoodles, Rocket Sage, oh, and Ian Stuckey. Has been doing accounting type stuff and also is known for doing other mathematical awesomeness. So go check them out too. Yeah. So I'm sure I missed a couple of people. I'm terribly sorry. I'll probably rotate through at various points and keep missing different people. So we'll see how it goes. Hope you all have a really awesome start to your week. We'll be back tomorrow for 9 Souls. So if anybody is interested in a totally cozy Tai Chi cat game, then we'll be doing that tomorrow. So we'll be running over to Dr. Gold, unless he is leaving. I don't think he's leaving. I think we're good for a little bit longer anyway. So, have a good night, everybody. Have a good start to your week. My name's Obi-Wan Pez. This is N Simple X Pachinko. Thanks so much for coming, and we'll see you next time.